Welcome to another tutorial of Prof and YouTube channel. In this particular video, we're going to have a discussion on how to solve logarithmic and exponential equations. This is a level Math P3 topic. We're going to have a detailed explanation on questions that we expect to do and also questions that have been tested before. In the first question, we're going to look at how to solve this kind of an equation, ln 1 plus e to negative 3x equals to 2. Now, if you look at this question, the first thing that we need to get rid of is ln. And to get rid of ln, we are going to introduce exponent both sides. So if we introduce exponent both sides, we're going to get rid of ln, and then we're going to have it as follows. So we're going to begin from the first part, e both sides, and then now you can see ln and ln is going to cancel out. We remain with 1 plus e to negative 3 equals to e raised to power 2. Now if we take the one on the other side, we're going to have e to negative 2 e raised to power 2 minus 1, and then we can now again introduce ln both sides so that we can get rid of the exponent. So you can see now this part again, we're going to remain with negative 3x equals to ln e2 minus 1. Now you can see now e2 minus 1 is a number, so which we can be able to plug into a calculator and get the answer. So we can also divide by negative 3 both sides so that we can remain with x, because the main objective of this equation was to find the value of x. But if you can see, we are told to give our answer correct to 3 decimal places. So that will mean that we can be able to plug this into the calculator. But if you are told to give your answer in exact form, that is the point where you are to leave that particular answer in this question. So we need to put this in a calculator, and if you work out, you're going to get negative 0.618 as our final answer. Now we can be able to move to another question that has been tested before in A-level P3 paper, and we can now work out a question whereby you are told solve the equation ln into x cubed minus 3 equals 3 ln of x minus ln of 3, and we are supposed to give our answer correct to 3 significant figures. So you take note of that. Now before we do anything at this point, I think we are going to use the laws of logarithms and reduce this to a point whereby we can be able to apply exponent and get rid of ln. So the first thing I can do, I'm going to use the laws of logarithm. One of the laws that we can talk about is ln of a plus ln of b. This can reduce to ln a plus b, ln a times b. So when two logarithms are added, then you can be able to multiply the numbers and then you get to a single log like that. Another law we're going to use is whereby you can be able to take n up, so that we can be able to say if you have n log a, then you can be able to write that as ln or log a raised to power n. So if you can look at this equation that we are given, we can be able to decide and take first we can use these laws of taking the power, the number behind the log up to the power. So we can be able to also take ln of 3 to the other side, comes as, so this is going to reduce to ln x cubed minus 3 equals to ln x cubed minus ln of 3. So that means we can be able to reduce it like that. So on the right hand side, what we've just done is that ln x cubed minus ln 3, that can be written as a single log, but we say x cubed over 3. Then we can introduce exponent both sides so that we can be able to get rid of or eliminate the ln, so that we can be able to say this cancel out, and then we're going to remain with x cubed minus 3 equals to x cubed over 3 times 3 both sides. or you can even take this on the other side. So whichever way that you feel that it suits you, we can be able to remain with this. So meaning I've just taken x cubed minus x cubed over 3, so that is 1 minus a third, that is the same as 2 over 3. Then you multiply by 3 both sides to get rid of the fraction. We're going to have this reducing to 2x cubed equals to 9, then divide by 2 both sides. The 2, then we can be able to find the cube root of 4.5, which is going to reduce to 1.65. If you are getting value from Prof Learn YouTube channel, consider subscribing so that in time we're going to upload more tutorials, you'll be notified. This is a series of all the topics that you'll be tested. This is a series that is going to take um, a few days in order to complete all the topics. So there is every reason as to why you should subscribe, also to support this channel by sharing it to your friends so that they can also benefit from it. So if you've understood how to work out this topic, and if there's another topic that you feel that it's a bit challenging to you as you're approaching your exams, remember, Prof Learn is going to upload it so that you can be able to learn. So consider liking this video, commenting below if it was helpful, and also subscribe. Moving to the next question, and you are going to notice that some questions are written just one, and you wonder, we have done question one, why are we having again question one? This I've picked this question in the order, in the way they are appearing in the year they were tested. So if it was question one, it will remain there. I've not changed anything, but I'm going to show you step by step how to go through, how to work through, how to work each and every question so that you can be able to get a better understanding on how to solve it. All right, without talking much, let's go and dive into the question. We are given ln of e raised to power 2 plus 3 equals to 2x plus ln of 3. We are supposed to give our answer correct to 3 decimal places. So now to work out this question, we are going to remember that this is one of the law of logarithm that we learned. So we can be able to say we are going to take ln of 3 on the other side, and we're going to remain with 2x on this side. And of course, this is going to reduce to that from the law I've just written. Then again, the next thing we're going to do is to introduce exponent both sides so that we can get rid of ln that is appearing in the numerator. So I have kind of just copied the part that I have there, and then I introduce e both sides, and then this and this will cancel out. We end up remaining with this part, which is actually number that's going to reduce. So we're going to have this expression. Then we shall take exponent 2x on the other side, we remain with 3. So this is going to be this part on the other side of the sign, which remain with 3 equals to e to 2x minus e to 2x. And you see now it's like we're having 1 at this point. So we can be able to say if we factor out exponent 2x and subtract 3 and 1, then we'll end up going to having 3 equals to that. And this is going to reduce to 2x. Then at this particular point, we can divide by 2, and then we're going to remain with e to x equals to 1.5. Now, in order to solve this equation, we're going to introduce log, and we're going to say ln both sides, and then this is going to reduce it to 2x. Let me just move this a little bit, then I can have enough space to write. All right, so we can introduce ln both sides, right? Let's write properly, and then divide by 2 both sides. Because we are supposed to give our answer correct to 3 decimal places, or rather, yes, 3 decimal places, we can be able to put this into a calculator, and we are going to get 0.203 as our final answer in that case. This will give us every reason to move to the next question, whereby we're supposed to show that the equation log 2x plus 1 base 3 equals to 1 plus 2 log x minus 1 base 3 can be written as a quadratic equation. And then in that regard, we are going to approach it in this way, right? I am going to take this on the other side, then I'll write 1 there. I will take these 2, remember this law, then I can take these 2 up, and then we end up having log 2x plus 1 over x minus 1, but I'll square this because there was that 2 that is in green, and equals to 1. Now I'm going to write this in index notation. If you are having log a base b equals to n, in index notation this is the same as a is equals to b raised to power n. So b is the base, n is the power, the answer is n. So I'm going to use the same approach in working out this question. So I'm going to say 2x plus 1 over x minus 2 raised to power 2 equals to 3 raised to power 1. 3, remember, is the base, so when it's we write in index notation, 3 is going to be the base, 1 is going to the power, which is equal to 2x plus 1 over x minus 1 raised to power 2. And now at this particular point, I can multiply the denominator both sides, and this is going to beautifully reduce to that, whereby we're going to expand this, and we have a quadratic equation which are distributed 3 inside, and then we rearrange that. We end up having 3x squared minus 8x plus 2 equals to 0. Hence, we are supposed to solve this equation, but you need to be careful that here we are having 4y. In the second part, we are having 2y, which was not the case in the part. So first, we need to work out the value of x, and you're going to use just the normal quadratic formula in order to work out this. So if you solve this, we're going to have our x equals to, let us just work it out, see what we're going to get. This is 4 plus root 10 over 3, or x equals to 4 minus root 10 over 3. But now remember, we were having 2x, we were having x, but in the second part, this is the answer we have gotten for x. We are having 2x, we're having x, but in the quadratic, we're having 4y. So we're going to say 2 instead of x here, we're going to say 2y, because the previous expression we were having 2y in 2x in the first part, and the second part we were having just x. So since we are having 4y, it means the answer, this part, this expression has been doubled. So we're going to write 2y equals to the answer that we have gotten. And the other one, with which we are going to simplify, as 6 there, because 3 times 2 is going to be 6, and then our answer for y gives us that. All right, so if you work it out, you're going to get 1.19. all right, the other part, we're going also to work it out, and we end up getting a negative answer in this case. But if you put the answer that you have gotten there, negative 0.14, if you put it in the logarithm, it's going to give us a negative log. And remember, there is no log for negative numbers. So anytime you get a log whereby you can be able to say log of a negative, that one we say there is no solution. We cannot be able to proceed. Our answer is 1.19 only. All right. Solve the equation 2 into 3, 2x minus 1 equals to 4 raised to power x plus 1. Give your answer correct to small places. And the first thing that we need to do here, we can actually say we can introduce ln both sides, so that we can be able to start working it out. So when you are having 2 into all 2 times a number, we can be able to split this further, and say this can split to the ln of 2 plus ln of that, so that we can be able to again take the power behind the log, and then also here we can take the power behind the log. Remember the laws of logarithm. And we can be able to open the brackets, and so that we can simplify this further. All right, and then we shall put those terms with x on one side, so that we can be able to factor out x and then have our simplified expression. So factoring out x, you can see we're going to remain with 2 ln of 3 minus 4. So you can see this 2 ln of 3 can be written as ln of 3 power 2 minus 4, which can also be simplified further. Yes, the right hand side has been simplified fully. We can be able to simplify this part also, and then we can place that, and we can also simplify this further by saying this is going to be ln of 9 over actually 4, and then equal to ln of 6 divided by ln of 9 over 4. Ln of 9 over 4, this will commit suicide. We're going to have x equals to ln of 6 over that, which is going to be given how, right? 2.21 as our answer. Solve the equation 2 raised to power 3x minus 1 equals to 5 into x raised to 1 minus x. 5 into 3 raised to 1 minus x. Give your answer in the exact form ln of a over ln of b, where a and b are integers. So a question like this, we are going to give it the approach we have given the previous part, whereby we're going to introduce ln both sides, and then we are going to open the bracket, and then we simplify and then factor x out, so that we can be able to get the value of x. So at this point, we can take the powers behind the logs, and this is going to be opened further, and we are going to have 1 minus x ln of 3, like that. Then we can also put the like terms together, so we can pick those which are having x, and we take them on the left hand side, and those that are just full numbers, we are going to put them on the right hand side. Here we're going to factor out x, so that we can be able to have an expression we can divide both sides. All right, so this can reduce to ln of 2 raised to power 3, ln of 3, and this is going to be ln of 30. And of course, if you have ln of 8 and ln of 3, can be simplified further by multiplying this. All right, so we are going to say this is going to be 24 equals to ln of 30. But we are getting actually 24 because ln of 8 plus ln of 3, we can multiply 8 and 3 and reduce it to a single log, and divide by ln of 24 both sides. We're going to remain with our x equals to ln of 30 over ln of 24, and that is the form was up to leave our answer. Solve the equation 4 power x equals to 3 plus 4x raised to power negative x. If your answer correct to 2 decimal places, 3 decimal places, sorry for that. Now, at this particular point, you need to remember that if you are having 4 raised to a negative number, it means it's the same as 1 over 4 raised to a positive number. So we can be able to say this can be us. Yeah, so this is a different question. Of course, now we can start looking at, we can multiply these both sides, so that we can get rid of the part. We are going to end up having this expression like this, because we are having e to negative x, it can be written 1 over e to positive x, whereby we can now decide to multiply all through by e, so that we can be able to get rid of the fraction. And then we can say now let, and say, okay, this is going to reduce to that. We can say let e to x raised to e to x equals to m. Now we substitute anywhere we have e to x, we put m, but the first part is going to be m squared, because we are having e to 2x, so meaning we can be able to say that is e to x raised to power 2. So that is going to be a quadratic equation, which we can be able to solve. And yeah, if you solve this quadratic equation and then we go back to what we said late, so we can be able to get the value of x. So in this case, we are going to get m using a quadratic formula. Whichever way you can be able to solve this, we're going to have two answers like this. So if you have e to x equals to -3 plus root 10, we can be able to introduce ln both sides so that we get rid of x e, right? So we're gonna have x and then ln of that, and this number that is inside the brackets actually a positive number, so we can be able to get the logarithm of -3 plus log root 10, and this is going to be -1.82. But in the second case, you see, we cannot, if we say e raised to power x equals to -3 minus root 10, we are going to introduce ln in order to find the value of x, but you cannot be able to find a log of a negative number. So in that case, we are going to say no solution. So we are going to stop here and say the answer is -1.82. Now, having done this question, we can now move to the next part. This is the question now we need to focus on. So we are going to change for negative x to a positive value, and that is done by putting it as a reciprocal. And then we're going to say let 4 raised to power x equal to m, which will mean that we can multiply all through by m in order to get rid of the fraction. And at this given point, we're going to form a quadratic equation, which we are going to rearrange like this, and then go ahead solve that quadratic, either using completing square method or a quadratic formula or factorization. But our quadratic equation cannot factorize. Now, since we had said let for be equal, for raised to power x for equal to m, we can be able to come at this point and then introduce decide and introduce ln both sides so that we can be able to solve for x. Because by introducing ln, you can be able to take x behind the log, and then we have the ln of 3 plus root 13 over 2, then we divide by ln of 4 both sides so that we can be able to get our answer in this case. So I believe if you are getting value, you can be able to leave a comment down below. If you can now work out question to do with logs without any problem. And remember, whenever you are finding a logarithm of a negative number, there is no solution in that case. Let's see if we have our last question, because here if you work it out in 3 decimal places, you're going to get 0.862. Now let us move to the next part. Always check the accuracy in which you are told to give your answer so that you don't make any mistake. All right, this question already we have done it, and I believe you have followed through what we were expected to do. We have done a question similar to this, and of course this reduced to that. So we can now let, we say now we can let e to x equals to m, then form a quadratic which we are going to solve, and then introduce ln so that we can be able to solve for x. So solving this, we are going to get our answers like that. And then once you get the answer, this is just a repeat so that you can be able to remember what we said. We introduce ln in both cases, and then we're going to have x equals to -1.82, and we said the other part is not going to lead us anywhere because it is a negative and we cannot be able to find a natural log of a negative number. So for today, we're gonna stop there and watch out for the next video.